see. All right. This. Hold on. Oh, come on. Think I am behind. Let's see what is here. Dun, 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 dun. Charts are loading. Hey, hello, Ransom. How are you doing? I'm good. I'm good. How are you too? I trust you are doing well. Yes. Sorry. I told you I was going to wear the yellow. Yeah. All right. Okay. Let's see. Today is day 88. So we have 12 more days to go. All right. Oh. Okay. Um so let's wait a little for more people to join in. And please don't forget to like the stream. Don't forget to subscribe. I'm threatening you all of you with subscription. Okay. Um all right. So we have a couple of questions to solve today. Now, I just realized I have solved almost all the easy question on linked lists. Almost all of it, not everything, but like most of the easy questions and a few medium questions. I'm becoming really better. Let me just say better at these linked list things, which is nice, right? Um, so we'll solve one more question. I've arranged the question down today, so we'll quickly do this. This is a question I solved yesterday, so we'll go over this, right, and then see how it is done. So, aside from that, yeah, so we have three, or how many questions did I set for today? I think I set four questions. One, two, three, four. Okay, that's right, four questions for today. So we'll go through this and yeah. Okay, now I think we are ready. I think I should start with the question I had already solved, right? Or should I start with a new question? I think the best thing to do is to start with a question already solved. So, intersection of this, I'll remove all of this, right? I'll reset the question board, and then I'll code everything out again. But we'll still go through and read and see what the question is about. Dun, 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 dun. Okay, so let's read this question. This question is actually very long, and I don't I don't really think there is a need to read everything. As I think when you read up to this point, you already get what the question is asking you to do. Even the image itself is already saying a lot. But let's still read it and see what's really about. So, intersection of of two linked lists. Given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. If the two lists have no intersection at all, return null. So for example, the following two linked lists begin to intersect at C1, which is here. So the test cases are generated such that there are no cycles anywhere in the entire structure, in the entire linked structure. Note that the linked list must retain their original structure after the function returns. The input to custom judge. The input to the judge are given as follows. Your program is not giving this input. Well, this is something very interesting as well. So intersect val is the value of the node where the intersection occurs. This is 0 if there are no intersected node, sorry. List A is the first linked list, list B is the second linked list. Skip A is the number of nodes to skip ahead in linked list A, in list A, starting from the head to get to the intersected node. Okay, these are just stuff how LeetCode evaluates your solution, and yeah, it's good to actually read. I'm not going to read that anymore. Let's really get the example. So here is an example. We are given two lists. In reality, this is a separate list, but this image is just portraying how the intersection happened. So here is two lists. We have this list here, which is the list starting from this point all the way here, and the second list will be from here all the way to this place, right? So there are two linked lists and they intersect at 8. So let's see what we can do. I will erase this part and go over my explanation again. All right. So to solve this problem, since we are looking for an intersection, there is going to be traversal of nodes, and we need to find where the nodes became equal, right? Now, it's not really about the value of the node. It is actually about the node itself and its connection to other nodes, right? So let's write out this. Let's go like this. I'll say here. Okay, let me read this quickly. The intersected node value is 8. Note that this must not be 0 if two linked lists intersect. Yeah. So the intersected node's value is 8. Note that this must not be 0 if the two lists intersect. From the head of A, it reads 4, 1, 8, 4, 5. From the head of B, it reads 5, 6, 1, 8. 1, 8. 4, 5. There are two nodes before the intersected node in A. There are 3 nodes before the intersected node in B. Note that the intersected node value is not 1 because the nodes with value 1 in A and B, second in A and third in B are different node references. In other words, they point to two different locations in memory, while the node okay, so this is another interesting angle I'm looking at this question. I actually solved this question. I know what to do, but I'm now realizing the node 1 and 8, 1 and 1, they both have 1, right? They both have nodes with value 1, where which could have been where the intersection happened, right? But this is saying that note that the intersected node value is not 1 because the nodes with value 1 in A and B, which is second node in A and third node in B, are different node references. What does that really mean? Are different node references. Okay, they point to different location in memory. While the node with value 8 in A and B, this is not very, very, very clear, except that we are trying to say, okay, the nodes before them, right, had other nodes. Which is kind of fair if you think about the previous node before whatever, you know, the next node is, or where the intersection happened. Anyways, let's go back to this and let's explain what's going on here. So we have two nodes. We have two lists, right? Two linked lists. The first linked list is 4, 1, 8, 4, and then 5. Okay, and we have 5 for the second list. Let me use a different color. For the second list, we have 5. Come on, we have 5, 6, 1, 1, 8, 4, and then 5. Now, these two lists have different lengths. That's one thing we can notice, right? And then we can say for sure that the intersection happened at 1 because, like the question said, they point to different location in memory, which is kind of, I don't know. Let's really see. Okay, I explained something yesterday about how nodes are stored, right? So I'll bring back my code editor here, and let's just run an experiment. And I really like this because it shows you what is really happening under the hood. So let's say we had let's create a node class. So I'll call this, sorry, node, and I'll set the properties of this node. So self, okay, let's define the constructor function of, we will need a value for our node. So this is that. So say self dot value is equal to value, right? Say self, come on, self dot next is equal to none for now. And let's create a node using this node class. So we instantiate a new node. I'll say n1 is equal to node here, which is going to be equal to 3, right? Node with a value 3. So let's print this node and see what's inside. I'll put print n1 like this, and you see we'll have like some strings, like a long string. So you can see we have a node object at this position. So this is the location of this node in memory, right? Let's print this again. You can see the value changes in every time we print. So I'm not sure. There should be an explanation to this, right? At least we know this is the location at which it is stored. So is the location really what matters when it comes to, you know, the node itself? Let's say we had another node with a value 3 also, right? n1 is equal to node at 3. Oh, let's call this n2, right? Node with a value 3. Okay, So these are two separate nodes, and let's say print node 1 equal to node 2, right? Let's try to compare them. This is false. So meaning they are not stored at the same location in memory, right? So this could also mean that the nodes are actually not the list, this linked list. They're actually, well, I'm not sure. Maybe the way they are. Let's read this part here. Say skip is the number of nodes to skip ahead in list A, starting from the head to get to the intersected node. So there is a custom jot to this, because naturally, right, I don't think, even if the node, so let's say this node has a next value, right? Sorry, let's say n1 dot next um is equal to a new node. So let's instantiate another node. I'll say node, and let's put this as 4, right? Okay, so n1.next is going to be equal, not this, is equal to node 4 here, like this. Okay, now this node has a next node, right? Let's also do the same thing here. I think the the actual implementation of this question is not really two separate lists. I might be wrong, but somehow I feel they are not two separate lists. They are actually there's actually a connection, right? That was implemented by that. There's a custom intersection that was done, right, in the problem itself. So we had to like really think about how to find the intersected node, because there is no way these nodes can be equal, except we say n1, right, n2 is equal to n1 like this, right? We do this, n2 is equal to n1, and then when we do this can be true. So meaning we are copying this next node to this node. But okay, let's say we had n2, right? N2, which is this node, and we say n2.next is equal to let's say n1 like this, and then we say then we compare n1 to n2.next, right? Then in this case, I think this will work. This is true. So I think the nodes are not the linked lists, both linked lists are not created separately. They are actually created by copying one part of the first node and set it to the next of one part of the first list and set it to the next of the second list. So, which is, one thing I'm really thinking about, because it can't be, created separately. There is a reference to one node from another node, right? Which is something that I did here. Let's say we created two separate nodes, although these nodes have the same values, but n2 is not directly equal to n1, right? Just because n2 has the same value as n1, it doesn't mean they are equal. They are not stored in the same location in memory. So this is one thing to note about this question. I strongly believe, I wish I had an answer for this, but like I strongly believe the nodes are not created separately. The lists, both list A and list B are not created separately. The list A was created separately, but list B, since we want to set an intersection, list B was created by copying part of list A and set it to the next of list B, right? Even if I did this, even if this node here, right, this node 1 was copied like this, right? So I set node 1, node 2 dot next to be equal to node 1, right? And okay, you know what? Let's create a separate node. I'll say intersect intersect. Okay, intersect is equal to node at 4, right? And then as I create this node 1 and set node 1 dot next to intersect, right? And then I set node 2 dot next to intersect as well, intersect. So let's say node 1, let's compare node 1 and node 2. What do you think will happen? This is going to be false, right? They are not the same. Even though we set the values, right? You can see they are not the same. These are two separate nodes stored in separate, location in memory. But if we did this, so now we have something like 4 connected to 3, and then 3 connected to two separate nodes, right? So let's say we add another node to this. Instead of setting this node, node 3, node 2's next to intersect, let's say node 2 next is equal to node 1 dot next, right? Now when we compare this is still going to be equal to false, but if we compare it with the next value of this, so if you say node 2 dot next and then node 1 dot next, right? When you do this, you see it is true. So meaning the list itself, we need to understand that the lists were not built separately, right? Which also brings the next question, right? If we have a list copied from one list to another, right? Meaning this list here, let's come back here. This second list was not really built this way, right? It is actually, let's come here. I'll copy this part. It was actually built like this. So it was actually built from here. So let's start. We started with 5. Okay, let me use a color like this. We started with 5, and then we have 6, and then we actually have 1, right? But then after 1, we copied the next node from this point. This is list 1, right? So we did something like this. We started from the head of list 1. So we did list 1 dot next, list 1 dot next, right? Dot next. So dot next will bring us to this point, and the next of this node is going to be this node here, which is why we had 8 copied here, right? So 8, 4, and then 5. Now we know the location at which this portion of this node is stored, right, will always be the same as long as we copy it by reference. So we are not creating a new value, we are simply copying, we are simply referencing another node, right? So meaning the location at which this portion is stored is still the same when we reference it and connect it to this new node here, which is 1, right? So this is what truly happens, and this is what this question is actually, asking us to find. So meaning if we iterate through the first list and store every value of the node in a set, then we'll be able to find out if any of this node actually existed in the set we created from the first node. So here's what we need to do. We can copy each node. So we'll create a new set. I'll call this set, I'll call this reference set. I'll say RS, right? Now RS will store the nodes itself in the set, right? So we can start from this point. This will traverse the head of the list all the way to the tail. So we start copying each node. Now we know this node will be, it will have some, unique, unique string, I'll just say 1, 2, 3, right? And then the next node we store is going to be this node. This will be, 1, 3, 2, right? And then, okay, let's just do it this way. Let's increment it. I'll say 1, 2, 1, 2, 4, 1, 2, 4, like this. The next node we store. Okay, you know what? Let's properly write this out so that the values are actually seen correctly. So I'll say rs, or the set of this node. We are trying to store every node in this list in a set. So we'll have something like this: 1, 2, 3. This is just some unique string that I'm trying to simulate. So don't get confused by this, but this is how it is going to be stored, right? This is just an example. So 1, 2, 3 will be like this. The next node is going to be node at this point, which is going to be, let's say, 1, 2, 4. The next node will be at this point, 8. I'll say 1, 2, 1, 2, 8. Let's just use it that way. Okay, let me do this so that it is actually, so I will use the last number as what is stored in the list. So this is going to be 1, 2. Okay, you know what, it doesn't make sense that way, so let's just do 1, 2, 1, 2, 3, 1, 2, 4, 1, 1, 2, 5, 1, 2, 6, 1, 2, 7. Okay, so this is how we store the first list in a set, right? So we keep unique unique occurrence of every node in the set. Now, one thing you might think is, oh, this will not have been stored in the set because it is 4. Well, we are not storing values in the set. We are not storing the values of the nodes in the set. We are storing the nodes itself. And we know the nodes will give us, this string here. They are not actual values. So let's print node n1 or n2. Okay, let's print n2 and see. Now you can see this is what it gives us, an object like this, and this is the location at which it is stored, and it will be different in every iteration, right? In every function call. So when we run this again, you can see it changes, right? It doesn't remain the same. The value changes every time. So this is what I'm trying to portray by writing this 1, 2, and 3, and so on. So for the second list, right, we will just traverse the nodes and find out if this node actually exists in our set, right? So here's what we need to do. So for the first node, imagine this node was stored at position. Let's say I'll use a different color. At position 1, 1, 3, 1. This is this node. So we find out if 1, 3, 1 exists here. 1, 3, 1 is not here, so we move on to the next node. This is 1, 3, 2. We move on to the next node. 1, 3, 2 is not here. We move on to this point. This is going to be 1, 3, 3. 1, 3, 3 is still not in this set, so we continue. But when we get to 8, right, now because we copied 8 by reference from this first list here, right, 8's value is going to be, let's say, 1, 2, 5, right? Now we know 1, 2, 5 exists in this list. So this is how we'll be able to determine the intersection. We know, okay, 1, 2, 5, we search in this map or in this set and see if 1, 2, 5 already exists in this set. If it exists, then we return this node because 1, 2, 5 is already here. So we return the node at 8, 8, 4, and 5, right? And this is how we find the intersection of two linked lists, right? Given that we actually understand how the lists are built. The lists are not built separately. Even if we have the same values in the list and they are built separately, the nodes will never intersect unless we copied a portion of one of the lists and set it to the set it as a node in the second list. Then we'll be able to determine where those two lists intersect, and obviously it will be at the position of at the position where we copied the node, right, which is 8 in this case. So 1 to 5 exists in this list. So we'll use a set to store every value in the list, and then we'll traverse the second list and find out if any node in that list actually exists in the set we created. And if it does, we return that node. Otherwise, we return null, right? So let's do that. Let's write the code for this. I purposely erase everything so that I can write it out and show you how it is done. So let's say we can make a reference of the head node of head of list A. Let's call this list A. So I'll say let's call this instead of calling it current, I want to type, you know, less code. So let's say CA meaning current node A is going to be head of A, right? Head of A. And I will say while current A is not null, so CA, then we traverse the node. So we create a set too. So I'll call this S. Okay, I'll just say nodes set is going to be equal to a set, and then we'll just do current set node set. Okay, node set and dot add the current node, which is CA, and then we set CA to be equal to CA dot next. So this way we'll move on to the next node and so on, right? So this is going to be CA dot next. And yeah, so at the end of the day we'll arrive at a point where we added all the nodes into our set. So the next thing to do is to traverse the second list, right? So I'll say, okay, let's do this. CB is going to be equal to head B. Okay, we say it's going to be head B, and we'll say while CB is not null, then we just find out if the current node value is equal to CB. So say CB if, okay, use a conditional statement to say if CB, right, CB in the node set, right, then we just return CB, right? Else we just set CB to the next node. CB is going to be CB dot next, and and yeah, so if we did this and we don't find the intersection, we can return null, right? So return none here. Okay, so let's run this and see. Now you can see it works, which is okay. So the time complexity for this is first of all, we are traversing the first linked list, which is obviously O of n. So when you are traversing every node in a given set of inputs, or every value in an array, if you are iterating through all of them, it is automatically O of n time complexity. So we have another traversal here, which is O of n as well. So two O of n's. So let's say O of m plus n. And the second one, in terms of space, we are creating a set. A set will take space in memory, and we're adding each value in a node to the set. So this will be O of n in terms of space. So let's submit this and see. As you can see, the solution works, but you can see the space is actually um, you know ranked very low or rated very low. So um but we are good with the time complexity, which is, I think, one of the things we really worry about. So yeah. Okay, let's move on to the next question. Let's try out the next question. Merge two sorted lists. Okay, so here's another interesting question that I think at first I did not understand, and I struggled with it a little bit, but I saw this like, oh, let me check if there are any questions. Sorry, I did not think about that. I am really, really sorry. Let's check the chat to see if there are any questions. Hello, Dan. Dan is in the chat now. Dan is here. How are you doing, Dan? Okay, so there are no questions, which means we can continue. All right, so the the next question we have. All right, okay, no questions, no questions. Okay, I think I can keep the chat open here for now, unless I might just want to see what is going on in my streaming software. So, but let me keep it here for now. Okay, so you are giving the, okay. I was saying I solved this question some time ago. I don't remember when, but let's check. So my last submission was in May, so I must really remember how to solve this question. At least given the fact that I've been solving a couple of linked list questions, this question should actually be easy. At first, it wasn't easy. If you are solving this for the first time, sorry, you're going to struggle with this. If you don't struggle with this, then it means you've either seen this before or you are really, really a genius. But otherwise, lead code is just hard, right? It's the truth. So let's read this question and see how we can solve this. So merge two sorted lists. Now we want to merge two lists that are sorted. You are given the heads of two sorted linked lists, list one and list two. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged list. Okay, so we are given two linked lists, two separate linked lists, sorted, and um, we want to return a sorted version of that list. Okay, so iterating through two lists simultaneously, right? So let's see. Um, I'm going to erase this part from the screen. We already understand that. So let's bring this here. Is it me or the color has changed? It was red before. Oh, interesting. All right, that was not part of the question actually. So let's see how we can solve this question. Now, first of all, the length of the list, right? Are we told they're equal? So let's understand certain things. We know for now that both lists have nodes arranged in sorted order. So from smaller nodes, from nodes with smaller value to node with higher value, they are sorted, right? Now, the number of nodes in both lists is in the range of 0 to 50. Okay. Um, node value, node negative. Okay, the node's actual value is going to be between negative 100 um and 100. Okay, and we'll have maybe 0 or 50 nodes in each linked list. So this is another range, this is another range, and both list 1 and list 2 are sorted in non-decreasing order. Okay, we know that already. All right, so now that's enough information. So meaning we are not guaranteed, the length of the lists. It could vary, right? Meaning one list could be longer than the other, but the point is the nodes are sorted regardless of what the length of each list is. So list 1 and list 2 is here. We have these nodes, right? And we want to return a new node, a new list with the node sorted and merged. Now, returning a new list means we have to create a new list at the end of the day. So here's what we can do. We can create a new linked list, right? And we know we can't create a list without a node, right? So we need to give the node value. So I'll call this a dummy list, and I'll set the node's value to 0. As usual, this is something I've done a couple of times, and I actually know now that if you want to have a new list, if you want to return a new list from another linked list, there is a chance you need to create a dummy node and then connect the values to that dummy node. So let's say we are going to traverse this node simultaneously. Let me go back to using my favorite color. So this is going to be 0. The dummy node will be connected to any of the nodes we choose here based on the condition we set. So we can traverse the nodes simultaneously. So we can use a while loop, right? And say as long as, I'll call this L1 and L2. As long as there is value in L1, right, and L2, okay, that was wrong. I'll just put L1 here. Okay, while L1 and L2, right, while this is still true, we can begin traversing the list. So in this case, we have 1 and 1, right? And we want the next value of this dummy node to be the least, the smallest value from these two. But when we compare here, we can see that both nodes have the same value. So here's what we can do. We can set the correct value of this node, right? Let's choose this one. Since it's the smallest one, we can just use this straight away. Even though this is also small, we can still use both of them. So if the value of this node is what we choose, right, we can set it here, and then we set the next node. So we are traversing the nodes, right? So let's say we are traversing the nodes, so we are at this position, or let me put a dot. Let me use a dot or a square. A square is better. A square is not better. Let's use an arrow like this, and then we are also here. So meaning in the first iteration, we compare these values, right, and we see they are equal, so we can choose either of them. So let's say we choose the first one, right? This is going to be 1, and then we point to the next node. So as we set this node here, as we choose this node, we will need to move the pointer from this position to the next one. So we'll move this from here. Come on. We'll move this from here to here, right? And then we keep this one at the same position and compare the values, right, in this case. So we have 2 and then 1. So we compare 2 to 1, and we know 1 is the smallest value or the smaller value. So we put 1 here as well, and then we shift. So once a node's value is set to our dummy node, into our dummy node, we shift the pointer, right? We shift to this point. So L2 is now this node from here from 3 to 4. L1 is now from uh from 2 to 4. So we compared the nodes at this position again, and 2 is the smaller one, so we set 2 to the next node. So this node here is going to be 2, and then we move. So after setting, we move this node from here to here, and then we compare 4 to 3, right? And 3 is the smaller one, so we move. Okay, so we move 3 to here and set 3 to the node, our dummy node, right? 3 will be here. Now we have 4 and 4, so we need to choose one. And when we choose one, we still need to move, right? We still move to next. And once this is next and we no longer have any other nodes, it means the iteration will stop, right? So meaning we will be left with L2 being equal to 4, and we will need to find a way to set it to the next value in our dummy node. So since we are here, we can choose 4 here. We can choose 4 from the first list, and this will be equal to 3 to 4, right? And then since L2 still has one more value left, right? We can just say, while okay, we don't even need a loop. We can simply take L2's value, because L2 will be marked at this position. L2 will be here, sorry. Instead of using this arrow, I can use L2. I can say L2 is here, and L2 is at this position. So we'll see the dummy node, right, dot next will be L2. So if L2 has a value, right, we'll just say dummy node, I'll put this dn, right, dn dot next. Although we'll use a tracker to copy dn, but let's say dn dummy node dot next will be equal to 4. So meaning we'll end up with something like this. We'll end up with everything here plus new 4, which is 4 here. So we do this, and then we return the dummy node dot next, right? Or the dummy node we created dot next, because we don't want to return a node with 0 in it, right? We have to return everything from this place to this side, right? This is our result at the end of the day. Oh, why am I? Okay, I don't know why I'm drawing like that. Okay, so let's see how we can code this out, right? So merge to sorted list. So we start from, we create a dummy node. So I'll call this D node, right? And oh, you know what? Let's call this fake node, right? I like to use. I don't know. I really, it's just in my head. I don't like associating stuff like that to, when you're learning. Anyways, so I'll use fake node. Fake node is going to be equal to a list node, because they are using a list node here as the node class. So say list node, we'll set this to 0. So this is going to be the value of our list node. So we copy, we'll copy this thing. So we say current node, or let's copy this node. We'll copy this. You know what? Let's use current node. I like to use current node because it's something I already have in my mind, that I always use current node to keep track of the nodes in the list, right? So let's say this is going to be fake node as well. So we are assuming the fake node is our head node, right? So fake underscore node. I don't want to type too much. I don't know why. I just feel like, I'm not really. So let's try. Let's travel both lists. So I'll say list one, and while list 1 and list 2, right? List 2 So what the boots are, they have some values. If list one's value, list one dot, oh, okay, list one dot value is less than list two's value, list two dot value, right? Then we set the current node underscore node dot next to be equal to list one else. So after setting the value, we have to change list one, right? List one to be equal to list one. Come on, I was just using one. List one should be equal to list. So we are moving to the next node, right? List one is equal to list one dot next else. If they are not equal, meaning list two has the smaller value, we say current node dot next to be equal to list two, and then we set list two to be equal to list two dot next, right? And we need to reset the current node so that we can add a next value to it. So say current node is equal to current underscore node dot next, right? And if we are done, when we are done iterating, right, and there is one node with more value left, there, let's assume it was list one. We'll say if list one, right, then we say current underscore node dot next should be equal to list one if list two, right, current node underscore dot next should be equal to list two, and then we can return the fake underscore node dot next. So let's see if there are any mistake. Okay, this works, and let's submit once again. Okay, it's a fair solution. We are not creating any space in memory. At least we were creating, a list node, but anyways, it's all good. It's all good. So let me refresh the chat and see if there are any questions. Who is SM Riti? I don't know. Who's this? Russell said, should I bring the loop? Stop breathing. This is hilarious. Spot on, Ransom. Yeah. I don't know. Is he trying to say something? Maybe not. Okay, so let's see what we have here. What is the next question on the list? I'm not even solving the question in the order I set them. Anyways, it still doesn't. Okay. Aha. Reverse words in a string. So this is revision for that word, for that question. So how do we reverse the words in a string? Well, we know, if you know how to reverse a string itself, right? this question is pretty much the same, but the only thing you need to do this time around is to remove white spaces. Where's the question? Reverse word in a string. So I use a two pointer method. I even used so yesterday ransom suggested the usage of it's a linear solution. It's just one line of code. I think this is it. Yeah. So you split the strings, right, and then return the reverse of it. Strip the string, we mean remove any white spaces. Reverse this, split it into an array, reverse the array, and then return the words in that array joined by a space. So, which is what we did here. Um, yeah, this was an interesting question, by the way. Ah, sorry, trying to stretch my wrist. What is the time? Whoa. This I keep saying this and it's funny to me. Um, I've not slept yet. I'll soon sleep. I'll soon sleep. I'll soon sleep. The sleep is coming. I think I have slept a couple of times on the stream, which is something you find. I mean, it's not strange, right? Teachers sleep all the time. Although I'm not really a qualified teacher yet. Looking forward to it. Okay, so let me explain how this question can be done. If you know how to reverse a string, this question will become very easy. So let's see how we can reverse a string first of all. So reversal of a string. So let me remove this part and show you how you can reverse a string. Now strings in Python are immutable, meaning you can't modify values within the string itself. So you need to have a reference or a copy of the string into another string to be able to modify the string. So let's say we can reverse an array, but we can't reverse a string directly, right? So which you can let me show you. You can't do something like this. Let's say um I'll call this word. So this is word. Oh come on. Word is equal to let's write safe, right? Now you can't do something like this. You can't say word at let's say 0, the first character in the safe word, and change it to say T. This is not possible. Already you can see you can't mutate strings, but you can mutate arrays, right? You can mutate the values in an array. You can change values in an array, but you can't do that in a string. If we print string, if we print the word now, you'll see we'll have an error, right? It say string object does not support item assignments. But if this was an array, this is perfectly fine. You can change an array, right? You can say, let me call this words and create an array of words. I'll call this save. Or let's say S. Okay, I can do something like this. I can split this into an array. W dot split, right? Oh, sorry, word dot split. This will split this into an array. So let's print words instead. Oh, sorry, I didn't split it with something. So So let's split it with space like this. Okay, it's still not splitting. Interesting. I thought, okay, if there was space in the word, it would have splitted. Anyways, let me just do a one line. Um, so I can create an array from this string. So I'll say character for character in word, right? So this will create an array for me of every string in the array. And then until then this is the point at which I can do something like this and change the string. I can't directly modify the string in Python. I don't know about other programming languages, but you can see this has been changed to T. But you can't directly do that to a normal string. You have to modify an array. So now, how do we reverse a word in reverse a string? So we can create a copy of we can create an empty string. I'll call this rev word, right? Rev word. Okay, list instead of arrays. I keep saying arrays because I use JavaScript most of the time, but anyways, list. So yeah, so that's a word. We create an empty word, an empty version of the reversed word, and then we can iterate through every character of this word and reassign the reverse version of this string, right? So let's say we do something like this. So for we write a loop. Let me close this part here. Oh, okay. Can say for character, we can even do it in a single line, right? But I don't want to do that now. So let's just write it out. For character in word, right? We can just say reverse word, right, is equal to the character plus the reverse word. So it's equal to character plus reverse word, right? And with this we can print reverse word like this, and you'll see the reverse version of the string, right? E became the first character, which was initially the last, and so on, right? So E, F, A, S, right? You can even do this with a can you do this with a list comprehension? Let's see. You can say return character, right? Character plus rev word. Okay, this is not possible for rev word. With this comprehension, you need to put in an array like this. Character. I don't want to create an array, but just rev word. Okay, this doesn't work. You can't do that. You can't do that. But anyways, you can see this is how you reverse a string. You create a new string from this. Now the question here gave us, instead of one word in the string like we had there, the question gave us a list of words inside a string, and then the words are separated by the words are separated by spaces, right? We have spaces. We can have space in the beginning, at the beginning of the string, and at the end of the string. So we need to find a way to eliminate this. Okay, like this, in this case here, we have hello word written like this, right? We want to be able to reverse the words in the string. We are not reversing each character. We are reversing an entire word, because the string itself is made up of a couple of words. So we want to reverse the words in the string. So let's say in this case we are reversing the string itself, a string that was created with just one word, right? So let's imagine we had spaces here, right? And we are trying to reverse the characters in this string. What do you think we'll have? We'll have the word printed with the spaces. Now you can see the spaces here. There's another space here from here to here. So we need to get rid of those spaces by using the strip method, right? We can say rev word dot strip, or we can just put the strip here, simply here, right? You can say the strip, and we'll strip everything away. When we print this again, you can see we no longer have those spaces in front and at the end of the string. So the same thing will happen in this case. So let's copy this part, right? So now we have hello world like this. We want to return at the end of the day. We want to return word hello, right? Still the same thing, but now we got rid of the spaces, and then we also have the first word and the second word, right? The second word became the first word, and the first word became the second word. So to do that, we will need to go an extra mile, right? We will need to first of all remove the white spaces or the trailing spaces, then split the word to have two different words, and then reverse it, right? So we can do something like this. We can say, we can do, I'll call this result. Result is going to be, first of all, let's strip the white spaces. We can strip the white spaces, then we split, right? We split the word. If we print this now, you'll see we'll have an array of words in it. So print res like this. You see we have hello and word, right, in an array. So what do we do then? We can reverse this array, right? We can reverse this array by simply doing something like this. So we copy the array, right, and then we reverse it just like this. So now we have word and then hello. So all we need to do now is to join them into a single string, right? We can just do this. So we can join them into a single string by separating them. So this is what they will be joined by, right? So say join this array. Now the join method takes an array, right? So this already returns an array of the reverse version of the words in the word string, and then we are joining them with a space. If you join them with a dash, it will be joined with a dash like this, but we want to join them with a space, so we'll do this here, and we join them with a space. Now you can see we have word and hello, right? Now another way you can do this is by using two pointers, right? Which is the I would not say this is not interesting, but like a two pointer is just like shows you a step by step of what is happening within this version of the reverse string. So with a two pointer, we can first of all create an array, then set the left and right pointer to the beginning and end of the array, and then swap the values, right? We'll swap the values at each position. So here's what we need to do. I'll just call this res. Res is going to be, so let's copy this part. So we strip the string and splitted it, right? So this will give us an array of the res. So you can see it's an array. So we'll put our left and right pointer at the ends of the array. So let's create a left and right pointer. I'll say left is equal to 0 and right is equal to the length of res, right, minus 1. So now we have to use a while loop to shift the pointers, right? So we'll say while the left pointer is still less than the right pointer, while left is less than right. Okay, so we need to do something. We need to swap the values, right? So we'll say res at left, right, and res at right. We'll just do res at left, res at right, sorry, before res at left. We'll assign them new values, right? So res at left. Okay, This way the values will be swapped, and we will increment the left pointer. So left is going to be increased by 1, and right is going to be decreased by 1. 1 minus. Okay. So like this, and at the end of the day we'll reach the end where the left is meets the right, and we can no longer continue the loop, and we'll end the iteration at this point. So we can say so in this case we can print res, right? Let's print res and see what res is. You can see word is now the first character in the array, and hello is the second one. So what do we do next? We need to join this as a new string. So we can say join as usual, join, and then we pass it the res, and then let's print this version of res. I mean, can we reassign res? Can say res is equal to this, right? Yeah, it's possible. Okay, now you can see we have word hello. So this is how you reverse the words in a string. All right, I think my time is up, but let's solve one more question. Are there any questions in the chat? Hello EW. EW, can you kindly tell me your name so that I will start referring to you by your name instead of EW? Anyways, okay, so let's continue. The next question we have will be convert. This is another interesting question. Convert binary number in a linked list to an integer. So given the head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number. Return the decimal value of the number in the linked list. The most significant bit is at the head of the list. Well, so we are trying to, we are trying to add values. Sorry, I got a bit distracted. We are trying to convert the nodes in a list into a base 2 integer. Okay, so we are trying to return the binary version of the number. So this is the entire number, right? So meaning we have to traverse the list and gather all the nodes value, and then convert the node values to a binary representation of the entire value. That sounds cool. So let's see how we can do this. I'll create a file. This is a new question, so let's create a file. So this is a linked list, so I'll create a new file. This will be linked list 1290. So lit code 1290, lit -1 1290. And what's the title of the question? Convert binary number in a linked list. So get decimal value. Okay, get decimal value. I'll say get decimal dash value. Right. Okay. So let's get the decimal value, and I'll copy this part of the question. I usually do this because I need it. Okay, so let's try and understand the question a little bit more before we start solving. Now let's see. Linked list. The linked list is not empty, right? So meaning we are guaranteed to have nodes in the linked list, so we don't need to handle cases where there are no nodes in the list. Number of nodes will not exceed 30, okay, and each node's value is either 0 or 1. All right, so I think we can gather all the values from the list and then convert those values to a binary version. Now I don't know how to do the conversion, the binary conversion, but let's see. First of all, let's traverse all the list. So say wow. Okay, let's create a current node. Current node is going to be equal to head, the head, and then we'll say wow current node, right? While there's a current node, we want to, okay, so we need to set the value somewhere, right? Interesting. So let's say okay, I can create a string called node values, right? It's going to be an empty string. I'll use this string to gather all the nodes values in the list, right? So I can say, wow, let's print this. We can say node values is going to be equal to node values plus the current node's value, current node dot value, right? So this will help us, accumulate all the nodes value, right? And you know what, let's try this. Let's print this out and see if it works. I'll just return node values and see if this actually works. So I'll copy okay, we don't have an example here, but let's say we have n1 is equal to node 1. Sorry, it's list node, right? Okay, list node 1, and then we can set n1 dot next is equal to node, okay, let's say node 3. Sorry, list node. I keep writing node. List node with the value 3. And then let's call this, try the solution. Print my solution is going to be equal to my solution. Solution is going to be equal to the solution class, right? And let's print my solution dot get decimal value, and I'll put in n1 here, right? N1, and let's see if we'll have 1 and 3 as a string. If it works, then we would only, oh, I'm not even done. Oh, okay, so we're adding, okay, we need to convert this. You can see the solution say can only concatenate string, not integer to string. Okay, so you can only concatenate. So what if we transform this into a string, right? Oh, you know what? I was not setting the current node. Current node, it should be equal to current node dot next. I almost ran into an infinite loop. Okay, we have 13, right? So this 13 is what we need to convert into a binary number, right? Or a number with 2 decimal place. Not 2 decimal place, but like a number, a base 2 number, a binary number, yeah. So how do we do that? How to convert? I don't know how to do this. How to convert number to base 2 in Python. What the hell is this? Wait a minute. I'm working on the number converter. Okay. This is way out of the scope of my question. Exactly. This place is where the source of truth is. I like using this resource a lot. Okay, function to convert to a binary number. You can use int, okay? But I want int to give you just the number, right? Format decimal. Hopeless. Does int take a second argument? If int takes a second, you can use int. Yes. Okay, I know. But if I use int, it will only convert the number to a decimal, a normal integer number. But I want a number to base 2, right? I think int takes a second parameter. I can see this here is dec and decimal, print decimal in binary, bin. Oh, okay. We have bin decimal. Interesting. Is this what it is? Let's see. Return. So we say bin, but this is binary. Is it base 2? Bin int of the current node. Sorry, node values. Node values. Does this work? Is this what we are supposed to return? Let's see the let's see the answer here. Convert to, yeah, nah, this is not what base 2. I don't want to start calculating base 2 by myself. Okay, let's do this. Let's say int node values. You know what? I was just being a judge of myself. Let's run this in Let's Code and see if this actually works. If it works, then it's good, right? So let's see. Oh, shit. Scheiße. This is not a valid value. So, okay, what if we did this? What if we did this? I don't know. Do we take a second parameter for int? Let's read about int first of all. Int node values. Buffer. Int takes a string, right? And okay. Bin returns a string with binary representation of the specified integer. Yeah, so we are trying to actually return the number in base 2, right? Want to return the number in base 2. Let's see if this will work. It works. It works. Let's see if this solution will actually be accepted. If it is, we are good. It's this is very interesting. So we can actually use. I just guessed that. I actually did not know. The reason why I guess that is because of the parse int that we have in JavaScript. You can do something like this: parse int to set uh, decimal places. I was just thinking maybe parse int is kind of int, right? This transforms a number to into you know a string into a number, right? But if you had pass int, let's say pass int, and then we set this to 2, can we do this? Run. It's not run. What's going on? Did you run? Okay, it says NN. Okay, okay, okay. Okay, okay. Fair enough. Okay, I would check this again. I think I did something like, is it pass float radix to this the specified number? Pass int. Yeah, so pass int 8. I said it. I've seen it before. I've seen something like this before. Exactly. If I pass int 2, what will happen? Exactly. So this is it. Ladies and gentlemen, we have come to the end of this stream. Thank you guys for being exceptional and participating in this party. So let me quickly push this to GitHub. I can do this. So say git add git commit, not fir, git commit. This is a linked list question. A linked list, and this is leads code number 1290. Git push origin main. Origin main. No. Push to GitHub. Okay. Tomorrow is Bright Friday. Yes, tomorrow is Bright Friday. We are going to continue tomorrow. Adios. Have a good night.